Statistical Process Control, otherwise known as SPC, is a set of methods that is used in quality control. SPC is meant to observe and measure the stability of processes and systems. What is meant by stability is that the data contains a normal distribution. The most important use or how of SPC is used is in maximizing your efficiency in your systems. So SPC is meant to look at the data that you produce, and then you take the information you learn and you take it back to your systems, and then you can adjust those systems in order to have them operate more efficiently, or at least in the way that you want them to. Another use that falls slightly outside of this typical description is with research. Researchers, they use run charts, which is a very important tool for SPC, and they use them to just identify where their outliers are, and then they can use that, and then they tend to throw out their outliers because they are not valid data points in their research. And of course, an important case that we need to look at is how engineers use SPC. So SPC can be used in engineering in looking at manufacturing, as in the amount of units produced on any given day, the average amount of units, or it can be used to look at individual materials or products and the qualities of those and how those vary from one part to the next. Here's an example of how SPC is used in engineering. This right here is a run chart. It is a chart of the tensile strength of string. So on the x-axis, you typically have a scale of time. So on here, it's the day of production. And then on the y-axis, you have the important variable that you want to look at. So for the string we're observing here, we're looking at the average force of failure in kilonewtons. And then the line right here is, of course, the plot of those. So your given force of failure, average force of failure on any given day. And then we have two bars here, an upper and a lower. These two bars are our bounds, and they're two standard deviations from the mean, which lies at 1.5. So the bounds are here to highlight what are our outliers. So we have 3 up here on the top and 3 down on the bottom. Highlighting these outliers makes them having these bounds makes it very easy to see the outliers, and once we know where the outliers are, we can go back and observe what happened on any given day to determine what caused that. Were there certain days where we had above average quality materials that were used, so it led to stronger strength or tensile strengths in our string? Or were there days that we had machine problems where either machines broke down or they manufactured the string in a little improper way, and so we ended up with frayed string? But either way, SPC and run charts in particular are very useful for engineers. It helps to quickly look at our data from day to day and be able to determine what's going on, and so we can adjust our systems based off of the information we get from them.